What we have seen so far in capacitor as oscillator, the theory part means if it happens, if capacitor nature is this, and if transistor is nothing but it is kind of dual diode, dual junction diode. It's not double diode, but it is dual junction diode. And if resistance kind of it generates a resistance when current flows. So then NPN transistor, PNP transistor fundamentals that we saw. Then we saw the working model means it actually oscillates, and if it oscillates, it generates noise. Okay. Now it's time that we'll see kind of currents. So currents are crucial. If we see any typical NPN transistor or PNP transistor. So it's a dual junction diode. So two junctions. So typically when we want a transistor to be in active mode, so we keep kind of one junction in forward bias and one junction in reverse bias. So NPN transistor like BC 547 we have taken. So if we keep kind of a base emitter junction as forward bias and base collector as reverse bias, then we can use transistor in active mode, and if its base voltage kind of go beyond 0.6 volt, this is what we are seeing, but I have seen kind of a specification 547 BC and it talks about 0.65 volt, but what we have seen, we are seeing 0.6 volt, so I have in front of me. So this is BC 547, and similar to this we have BC 557 as PNP transistor. So if a voltage goes above 0.6 volt, then means base voltage, then it starts kind of then a base emitter junction becomes kind of forward bias, and if become a forward bias diode, then it starts conducting electricity. So now we'll see in practical way that we talk about that voltage level at base, voltage level across the capacitor, it grows. So if voltage level develops because it is accessing voltage from VCC, from the power, and this makes the base voltage come up, and base voltage, if it is crossing the kind of the threshold, after which it will become conducting active, then NPN transistor become active. If NPN transistor become active, then it makes PNP transistor become, means this is how it is connected. Okay, and transistor is on. If transistor is on, then capacitor kind of it finds a path. Earlier transistor was switched off, so capacitor has only one path, that to be charged from the voltage source. Now, if capacitor when a transistor is on, capacitor gets chance to kind of get there is another path. Now there are two paths. One path is from VCC, that voltage is coming, and another path is from base to emitter. So that path, capacitor start discharging. Unfortunately, if capacitor start discharging, transistor base will be at one level because it has inertia, so it will be active. But if capacitor goes beyond a point in discharging, then transistor will become inactive immediately. Okay, so transistor is behaving like a switch. It will be active for certain duration and it will go off. So capacitor behaves like either it charges from the battery or it behaves like a power source, where it is discharging through base emitter diode junction, but it keeps the transistor circuit active also because it has voltage, but it has limitation. When it discharges more, then everything goes switch off. Then it starts charging. So when it is switch off, the path toward the transistor for the capacitor is dead. There is no path there. It starts charging again. So we have used 10 kilo ohm resistance in series with the kind of capacitor to the base, and from base to voltage source it is 330 kilo ohm resistance. So those characteristics we'll see. Now we'll also see that the sound that comes from the capacitor, that sound is not the current sound. That sound is kind of a transition sound. Okay, so if transition happens, current in the transistor circuit, if suddenly transistor circuit becomes active, then there will be kind of big flow of current through the speaker in kind of 200 milliampere, that way. So sudden flow of current, 0 to sudden flow, it will spark. It will speak, tick. Then from that much high level, suddenly if it drops, then it will make tick. Okay, so two tick we hear, and that two tick, it keeps repeating. So that's what. Now in the practical way, we'll see how much current flowing through the through speaker, how much current flows through the collector of the transistor PNP, how much current flows through the emitter of the NPN, base of the NPN, and through the capacitor, charging, discharging, everything. So then we'll try to kind of stick to kind of the voltage relationship in capacitor at particular time, what is the voltage and its exponential form of equation. That anyway we have done in the past in the tutorial. So that we'll use and we'll kind of try to verify. Means the idea is, if transistor is taking this much time to discharge, the capacitor is not getting charged fully. The full voltage source what we see is higher, but capacitor will come to a stage. So we don't know. Means capacitor from 0, it come to a stage till transistor circuit becomes active. It has to come to this stage. As soon as it becomes active, then capacitor will start discharging. As soon as it comes to a level, it is not 0. It comes to a level where transistor will become inactive, then it will start charging again. To a level where transistor will become active. So it will never come to a stage where it will get the full energy from the battery. Okay, so that calculation would be kind of difficult, and I don't know how much practical it is. But what I believe is the capacitor charging and discharging. So what I believe is the capacitor charging and discharging, that is kind of logarithmic or exponential, whatever the equation is. So time should be same. So if I charge a capacitor, then it charges immediately. Then slowly it becomes slow. At the end it will become very slow. If I discharge it, it will discharge immediately. And slowly it will become very slow. So if I calculate the kind of discharging time, then through that we'll try to manipulate something and we'll see that how much it is practical. It may go beyond what we are doing. Means we have to go with the kind of a transistor resistance, capacitor resistance we have to calculate practically, how much it is changing and like that. So that should be done. Okay, so that we'll see now. Okay, so we have kind of as we stated, we have finished the kind of showing the output. Now it's time that first we'll measure the components, and once we finish the measuring the components, then we'll start kind of measuring the current. Okay, so before we proceed, first we'll make it sure that it is working. Okay, so it is working. Probably it is kind of 4.7 microfarad capacity. Okay, now we will measure the resistance of speaker. First step. Okay, so it is 8.5 ohms capacitor ohm speaker is. Okay, so I am trying to calculate voltage of the battery. So we are using different battery. So it is coming around 3.69 volt. So this is the kind of new battery we are using, and it comes to this much. Okay, so we are done with the kind of measuring the component. Now we will measure kind of voltage across capacitor and voltage and current across capacitor, voltage and current across the speaker, and then emitter current, collector current, okay, base current and base voltage. Then we can kind of interpolate the others that can also be calculated. Okay, so what we'll do now? Okay, so this is, if we see, then this is IB, this is IB, this is IE, this is IC, okay, so IC of the PNP, okay, so, and we call it kind of, this is both way, so this is, we'll say I capacitor, okay, that will measure, so we'll measure IB, and here the voltage would be VB, okay, this is IE, and this is IC, okay, so PNP, and we can call it as I capacitor. Okay, so these things will measure, and then we'll see kind of how whatever we have kind of seen in the theory part, so it actually kind of corroborate. So that is the idea. Okay, so that we'll see now. Okay, so we'll proceed on the demonstration. So circuit is connected. So what I'll do is kind of, I'll connect the 4.7 microfarad capacitor, and first I'll show that it is working. Then we'll proceed with the measurement. Okay, so it is working. It is in working condition. Now I have taken kind of one 750. It is written 1000 microfarad, but we have already calculated in another tutorial that it is 750 microfarad actually. So if that is the case, then the operation should be slow. So if it is slow, then we can measure kind of calculations more neatly. So first I will calculate the IE So in the NPN transistor, whatever the current is flowing, so that I'll calculate. Okay, so now it should kind of oscillate. First of all, it will take little time charging and discharging. So probably it is charging now. Okay, so we heard one sound. Okay, so two sounds we can hear, charging and discharging. So now I'll measure the IE. What is the emitter current? So that is one of the crucial thing. So I can kind of disconnect it and we'll calculate. So this is the wire that is coming from emitter. So I'll just kind of make it round with ammeter. So we will have an ammeter. Okay, so now, okay, so I have placed at ammeter, and so this is one side, and another side of ammeter is already connected. So it should show reading. So it should oscillate and it should show the reading. Okay, so first sound we heard. Now capacitor is charging. So when it is charging, there is no current in IE. Once it is charged and when it is active, at that time the IE will be around 2 milliampere, and then when then capacitor will get a chance to kind of discharge on that path, and it will start reducing. Okay, so the region what we saw now, so that is kind of active region of the transistor, but since capacitor is discharging, so at one moment it will cut off. So now it is cut off and capacitor is charging. So this is IE, and IE reaches 2.22 milliampere. This is what we have seen. It takes around 30 seconds to charge and 4 seconds to discharge. So it is charged, discharging, discharge. So transistor is becoming active and passive, cut off in during this phase. We'll kind of quickly we'll measure the collector current of the PNP transistor. So I'll connect it as this. Okay, so this is PNP collector. PNP collector. So that current will measure. So okay, we have connected the ammeter, and ammeter will be connected here. This is okay. Ammeter will be connected at speaker end. So this will circuit is complete. Okay, now we can see the. So capacitor is charging. Around 130 milliampere current is flowing through IC of the collector of the PNP. So that much is required to make the speaker make sound. So now capacitor is charging. Okay, around 130 milliampere current is we can see. So then it is started discharging and IC is decreasing. At one moment transistor circuit will be cut off. So capacitor is charging again. So this is IE, NPN and IC. So both we saw. 127 it goes. And around 102 milliampere transistor goes cut off. So up to from 127 to 103, I think that period capacitor is discharging, and beyond a limit capacitor is kind of, then it is switched off. So next we will measure IB, then we will measure current in the capacitor. So capacitor one end we can take out, so we will reconnect it the way it was. Okay, so it was like this. So collector was connected here at the speaker end. Okay, now we will see the current flow in the capacitor. So capacitor one end will connect to ammeter again. Okay, this is how it is. Okay, so we have taken out the capacitor and we will measure current. So first it should oscillate. Okay, so it is, first of all it is oscillating. Okay, now it's time for capacitor current measurement. So current, we can see current is decreasing, means it is charging. So capacitor is charging. So right now it is 10 microampere current is there. Capacitor is discharging. Okay. So now capacitor is charging. So when capacitor is charging, at the initial phase there will be maximum current, that is 11 microampere, and it will decrease. So it will come to 10 microampere. Then suddenly it will kind of start discharging in reverse. Now it is positive current. Okay, it reached minus 9 volt. So 11 volt to 9 volt, 11 microampere when it started charging, and it reaches up to 9 microampere. Then it will go in negative, in the sense that capacitor current will be reversed. First it was charging, so capacitor current was kind of from battery to the capacitor. Now capacitor to the circuit, so it will be in minus. Okay, so it reaches minus, I think 30, we'll see again. Minus 90, minus 35. So when it starts charging, minus 90 microfarad, means 90 microfarad current starts from capacitor. So, and then around minus 30, it kind of goes before transistor is switched off. So now transistor is switched off. Minus 92 to 34, that much it goes. And while charging, at the beginning it will be high current, 11 microampere, and then it will go to 9 microampere before it starts discharging. Minus 92. Okay, so around minus 34, 32 it goes. Okay, now it's time to measure the VB. So we will kind of release it. Okay, so capacitor 750 microfarad capacitor. So we will connect it back. Probably we will kind of measure voltage across capacitor, then we'll measure the VB of the NPN transistor. So voltage across the capacitor, if we want to measure, then we'll put in voltage mode. Okay, and then this is negative, and now we will kind of take out and okay, so voltage across capacitor is changing. We can see now. So it is going up to 30.34 volt and decreasing, and it is going up to -6. Okay, it is charging. Charging, and it is going up to 0.3. 0.3435 volt, now discharging, and -0.06, then it is charging back. -0.06 means it is 0. Minus it is going because there is a voltage drop across the speaker, and since it is in other kind of polarity, so capacitor is going in negative. So it is kind of charging from other direction. Okay, so now it's time that we'll measure the VB, the voltage across much awaited. So we'll place this into sync mode, and here, so much awaited VB we will measure now. Okay, so we have connected a wire in the VB. So VB is VB is growing. .62 it reaches. So that is conduction mode and not discharging. Okay, voltage is growing. So capacitor is charging. Okay, so voltage at the kind of base of the NPN transistor, it reaches more than 0.6 volt and it remains there at that voltage, so that it will be active for some time, and then it becomes non-active and it drops. So now voltage is growing, so circuit is kind of cut off, capacitor is charging, and okay, so it remains there for some time. Okay, and when it falls, at that time capacitor was at was charged for some, so 0.11 it starts. So VB is in beyond 0.6 volt. It is showing in the conduction region, active region, and this is how it is. Okay. Now next question is kind of can we measure? Okay. So we have measured emitter current. Okay. Now we will measure base current also. So base current would be kind of little tedious to measure. So we'll put in ammeter mode and we'll take out this. Okay. If it is in base current mode, then we have to take out. Okay. So resistor would be now. Both resistor we have to take out. Okay, and okay, so we have connected the base somewhere other place, and now we'll connect ammeter. Okay, through ammeter current would go. So ammeter is connected to base. First it should oscillate, and then we'll connect back the. Okay, it's working here. So this is IV, base current of the NPN transistor. So base current is 0. There is 0.0. Okay, 1 micro. So there is no. It's transistor completely switched off. There is no current going in the transistor. One 19 microampere current goes and it comes down. Okay, so when it is active at that time, 119 microfarad, that much is the kind of current flows. At the beginning, current will be maximum. It will slow down as capacitor kind of discharges. Okay, I think ammeter is not kind of very nicely functional. It is oscillating too quickly. This is what we can see. Okay, so in kind of microampere range. 160 and 53. It oscillates between two kind of current range. Now we will kind of we'll measure the voltage across the speaker, how much voltage drop it is making, and then we'll wind up. So I think we understood how it is. Okay, so we have connected it again. Okay, we place in voltage mode and we'll measure the voltage across cap. First it should oscillate the way we have made the connection. Okay, so we have made the connection. It should oscillate. Oh, it's oscillating. So 1.4 volt it goes along the speaker and 0.1 volt. We'll wait and see more. .4 volt and 1.1 volt. So the voltage across kind of capacitor along the speaker, it kind of oscillates from 1.4 volt to 1.1 volt. So that is primarily from the collector current from the PNP transistor. Okay, so the collector current in the kind of NPN transistor and then emitter current in the PNP transistor. So those things can be kind of interpolated with the emitter current in the what we have calculated. Okay, so we'll bind up now.